everybody. I hope you guys are having a wonderful day. In this video, we're going to talk about how you can use benchmark fractions to compare fractions. So the benchmark fractions we'll be using are the fractions 1/2 and sometimes 1/4 if you happen to notice that that would work. But 1/2 is definitely the most common. And then we'll also be using whole numbers like 1, 2, 3, 4, 5, etc. So, the way that you compare fractions with benchmark fractions is you look at the fractions you're trying to compare and you see if one of them is bigger than a benchmark fraction and one of them is smaller. So, in this case, we have 5/8 and 3/14, which are both smaller than the whole numbers 1, 2, 3, and so on. So, we won't be using those benchmark fractions. But if we look at the benchmark fraction of a half, um, 5/8 is bigger than a half, and 3/14 is smaller than a half. And the thinking behind how I know that is if you have a circle or anything, it could be a number line or a rectangle, whatever you want to use as your model, but I'll use a circle. And if I cut that circle into 8 pieces, half of those pieces will be 4 of the 8s. And since 5/8 is more than 4/8, that means that 5/8 will be bigger than a half. Similarly, if I look at 3/14 and I cut a circle up into 14 pieces, well, half of those pieces are 7/14. And since 3/14 is less than 7/14, that means that it's smaller than a half. And so the fact that one of our fractions is bigger than a half and one of them is smaller than a half means that the fraction that is bigger than a half will also be bigger than the fraction that's smaller than a half. And so that's the basic idea behind using benchmark fractions. And when you're teaching this to your students, you can show them visuals to kind of help them understand this. So like if you have 3/7 and 2/3, again, an easy benchmark fraction would be the fraction 1/2. And since 3/7 is smaller than a half and 2/3 is bigger than a half, that tells us that 2/3 is the bigger fraction out of the two. And so that's how you would do that. So why don't you guys try this one on your own? Pause this video, see if you can figure out which benchmark fraction would help you compare these fractions, and then I'll go through it with you. Okay, so on this one, we have 1/3 and 2/9, and both of these fractions are less than a half. And so the thing that I would use to compare the fractions is the benchmark fraction of 1/4. And if I use the benchmark fraction of 1/4, I know that 1/3 is bigger than 1/4 because the pieces are bigger. Like if you have a circle cut up into 3 pieces versus 4 pieces, the one that's cut up into 3 pieces will have bigger pieces because you're splitting it up into a smaller number. And so 1/3 is going to be bigger than a fourth. And if I think about the number 2/9, I know that 1/4 equals 2/8. Like that's a equivalent fraction for 1/4. And 2/9 is going to be smaller than this because, again, if you have a circle that's split into 9 pieces versus 8 pieces, the 9ths are going to be smaller than the 8ths are. And so this is kind of using the idea of common numerators to figure this one out. And so since one of the fractions is bigger than a fourth and one of them is smaller than a fourth, that means that we can use the benchmark fraction of 1/4 to say that 1/3 is bigger than 2/9. Now, I would actually probably not use this method for this problem. You could use it, but we will be learning about some other methods that would likely be easier to use for this comparison problem. So usually I end up using the benchmark fraction 1/2 and then the whole numbers the most, but you can also use 1/4 as a benchmark fraction as well. So let's do one last example where we order these fractions. So we have the fraction 3/4, 1/5, 7/3, and 9/2. So I'm going to look at each one of these and see what I can figure out about these fractions. So when I look at the number 3/4, the benchmark fractions that it's in between are the benchmark fractions 1/2 and the whole number 1, because 3/4 is bigger than 1/2, but it's smaller than 1. If I look at the fraction 1/5, this fraction is bigger than 0, but it's smaller than 1/2. And so those would be the benchmark fractions that this one is between. And technically, we could also say that it's smaller than 1/4 if you wanted to. That would give you the same result. And then the next one, 7/3, this number is going to be bigger than the number 2 because 2 is the same thing as 6/3, and 7/3 is bigger than that. So 7/3 is going to be bigger than 2, but smaller than 3 because 3 is equal to 9/3, and 7/3 is smaller than that. And similarly, for 9/2, the number that it's bigger than is 4 because 4 is 8/2, and the number that it's smaller than is 5 because 5 is 10/2. And so I can order these fractions by looking at where they fall on the number line. So I'm just going to draw in my benchmark fractions right here. So here's 1/2, here's 1/4 right here. And our 3/4 number is going to fall about right here. So this is where 3/4 is at. Our 1/5 number is going to be between 0 and 1/2. And we also talked about how it's actually between 0 and 1/4. So it's going to be somewhere over here. And then 7/3 is between 2 and 3. And it's going to end up being about right here. So that's the 7/3 mark. And then 9/2 is between 4 and 5, which is going to be right here. And so by using these benchmark fractions, we don't necessarily have to cut our number line up into exact thirds or exact fourths or fifths or halves. We can just kind of estimate about where they're going to be on the number line in order to put them in order. So our smallest fraction would be 1/5. Our next smallest fraction would be 3/4, then 7/3, and then 9/2. So that's how you can compare fractions with benchmark fractions. If you have any questions, please let me know.